Hello again. All right, here's proofs 2, lecture. This isn't proofs 2 exactly, right? This is proofs 2 lecture, as you see there at the top. Okay, so the same basic format as the proofs 1 lecture. First, we see a proof here that is or we see a situation here where the proposition is true and the proof is correct. So for this one, you would select A. All right, let me talk about all the different things that make it correct. Okay, so first of all, if you look in part B here, the first reason why a proof may not be correct is because not all the assumptions are stated. Okay, here in our proof here, the assumption, right, if you remember, if P, then Q. So this is P here, and this is Q. So really, stating the assumptions is just to write down whatever the if part is, whatever P is. So you can see I've written that down right there. Okay, so we've got that. A rule of logic is used incorrectly. Let's see, that didn't happen. One or more of the equations used in the proof are incorrect. No, they're all correct. Let me go ahead and talk about that real fast. Let's see. So we're going to look at this line right here. Using the rules for exponents, we obtain that -1 to the x. Okay, so we've already said that. Let me mention something else first. Okay, so see this part here, part 4, not all of the variables have been defined. Okay, so we did define all the variables in this problem, and that happens right here. X equals 2n plus 1. That follows directly from the fact that x is arbitrarily odd. Okay, so because x equals 2n plus 1, where n is an integer, this first part here, this is just substitution. We're substituting 2n plus 1, which we said is equal to x, in for x there. You see that? I get to the next line. Okay, and then this part here, this line here, remember that if you have the same base, then you add the exponents. So -1 to the 2n times -1 to the 1 is -1 to the 2n plus 1. So you add the exponents. That's how we got that there. Okay, now this next line, how do we get from here to there? Okay, you may remember a rule from, so we'll look at that one. Let's see, I'll point to it from the top here. We're going to look at that one right there. That equality there, why is that equal? You may remember a rule from calculus or something. Let's see, if you have x to the m to the n, that's equal to x to the m times n. Okay, so here if you think about going back this direction, -1 squared raised to the n power is -1 to the 2 times n. Okay, so that's what we did there. And then this last, well, second to last, I guess. -1 squared is 1, so that's why we get the 1 to the n there. And 1 to the n is 1. 1 times negative 1 is 1. That's how we get that. Okay, so those are correct. And then just in conclusion, concluding everything there. Okay, so all the variables have been defined. No rules of logic were used incorrectly. All the equations are correct. And everything followed directly from what came before. What's going on with that? So, first we just state the assumption, right? It's like, where do you start? Where do you start? You start with the assumption. State the assumption. Okay, what does the assumption tell you? Let's see. The assumption is that x is an arbitrary odd integer. Okay, that tells me that x is equal to 2n plus 1, where n is an integer. Okay, now where does that take me? That takes me to, leads to this next thing. And that next thing leads to the next thing. That's what I mean by logical flow, or everything follows from the thing that came before.